The climate isn't everything, but it's not nothing. I absolutely love starting with this quote because it hits the nail right on the head. It perfectly captures the nuanced, incredibly pragmatic tone of Stephen Koonin. Today, we're going to dive deep into his specific perspective on the state of our climate. We're not here to take sides today, but rather to impartially and systematically unpack his exact arguments using the data and statements straight from the source.
Welcome to The Explainer. Today, we are neutrally breaking down the key arguments presented by Koonin when it comes to climate data, predictive modeling, and what he calls the catastrophization of climate language. As we roll through these slides, we'll look at exactly how he interprets the current science and why he firmly believes the conversation around our changing planet has become heavily skewed.
Here is our quick roadmap for today. We'll start off with the existential threat question, then dive into observations versus climate models. After that, we'll look at his take on sea levels and extreme weather. And finally, we'll wrap up with the core scientific challenge. Let's jump right in.
All right, Section 1, the existential threat question. To really grasp Koonin's views, we first need to establish his baseline premise on the reality of climate change itself. A really common misconception about Koonin is that he outright denies global warming. Actually, scratch that, he doesn't deny it at all. He totally accepts that climate change is real and that the globe is warming. In fact, he points out that on land, we've observed a gentle warming of about 1.2 degrees Celsius since the year 1900. He completely agrees with his foundational data point. So what's the real catch here? It's all about how that warming is framed. He believes climate change is for sure an issue we have to deal with, but he forcefully argues that it is absolutely not an existential threat. We literally hear that phrase daily, right? But Koonin points out that major scientific bodies like the IPCC do not actually use that catastrophic language to describe our current situation. Which begs the question, if the primary scientific bodies aren't calling it an existential threat, where on earth is that language coming from? Well, Koonin attributes this injection of existential dread to three distinct groups: politicians, the media, and certain scientists. He argues that this catastrophization has completely lost its credibility with the public, mostly because the apocalyptic predictions just haven't materialized. Moving right along to Section 2, observations versus climate models. Let's explore how Koonin fundamentally separates the hard data we already have from the predictions we make about tomorrow. For Koonin, there is a massive line drawn in the sand when it comes to the science. On one side, you've got observations of the past and current climate systems, the cold, hard data of what has already happened. On the other side, you have the modeling, the predictions of what the future climate will be. Both are technically science, but they carry drastically different weights of certainty. When we look into the future, things get incredibly tangled. Koonin points out that predicting what the climate is going to do 40 or 50 years from now relies on heavily complicated models. And to make matters worse, you have to combine those models with huge assumptions about what human emissions will look like down the road. It's an incredibly difficult scientific puzzle, and it's exactly why he titled his book Unsettled. The science of what the climate will look like decades from now is just pretty murky. And to emphasize just how murky it is, Koonin shares a rather mind-blowing insight. You know the experts who actually build these wildly complicated models? According to Koonin, even they don't put much stock in their own 40 to 50-year predictions. They completely understand the inherent uncertainties and the sheer number of variables at play. So you might be wondering, how do scientists actually figure out if a model is any good? Koonin notes that past climate observations are absolutely crucial here because they serve as the ultimate test. It's like this. You take a predictive model and you run it backwards to see if it can accurately reproduce known past climate conditions. If it can't accurately predict the past we've already observed, well, its future predictions are going to be highly questionable. That brings us to Section 3, sea levels and extreme weather. Let's weigh the public perception against reality and see how Koonin reads the historical baseline. To illustrate exactly why he is so skeptical of catastrophization, Koonin shares this incredibly relatable anecdote. Over 25 years ago, he remembers waking up to the front page of a highly respected Australian newspaper. The headline confidently declared that by the year 2025, the waters of Sydney Harbour would literally be washing at the doors of the Sydney Opera House. Well, 2025 is here, and as he dryly notes, the waters are definitely not lapping at the doors. The prediction just came and went. To ground this in some actual data, Koonin looked up the precise rate of water rise at Fort Denison, right there in Sydney Harbour. And the actual observed reality? The water is only going up by about 8 millimeters a year. Over the course of a century, that translates to about 8 centimeters.
While he totally acknowledges that sea level rise has its variability and is a little bit faster recently than it was over the entire 20th century, he makes a super vital comparison. He points out that the water was actually rising just as fast back in the 1930s. Because of this, he concludes that the whole idea of the oceans suddenly rising up and completely inundating us is entirely out of step with historical observations. And this perspective applies to extreme weather, too. What about the major storms, the floods, and the severe droughts we constantly see in the headlines? Looking at the long-term historical data, Koonin asserts that we actually haven't seen much change at all. Despite the gentle global warming we talked about earlier, he basically summarizes extreme weather events as business as usual. He argues that they're still operating totally within the bounds of natural variability. So in his view, the climate isn't broken.
What about the melting ice caps? Koonin reminds us to look at the broader geological picture. Earth is currently in what's called an interglacial period, a naturally warmer phase within the ongoing progression of ice ages. Because of this, he states it is entirely natural that the ice cap in the Arctic is disappearing over time. On top of that, he points to observational data showing that for the last 20 years, there's actually been very little change in sea ice overall. Which leads us to our final stop, Section 4, the core scientific challenge. Having laid out his views on data versus models, what does Koonin see as the ultimate hurdle for our future understanding? The climate changes. That is an undeniable fact for Koonin, but it changes in response to two extremely distinct forces. On one side, you have these massive, ancient natural phenomena. On the other side, you have growing human phenomena, specifically the impact of rising greenhouse gas concentrations. Both of these forces are pushing and pulling on the climate at the exact same time. And this leaves us with the ultimate million-dollar question from Koonin's perspective. How will science successfully disentangle natural phenomena from growing human impacts? That, he argues, is the true, formidable challenge in climate science today. We have to figure out exactly how the climate is responding to our greenhouse gases versus how it's just naturally responding to the Earth's own cycles. It requires pinpoint observation, incredibly rigorous testing of models, and, according to Koonin, a massive step away from the catastrophic rhetoric. Understanding the boundaries of what we actually know versus what we're merely predicting is just step one. The real challenge is separating the two. So what do you think? How do we strike that balance?